Dear colleagues, my name is Dmitry Morozov, and today I want to present you our work on transformer-based approaches for lemmatizing abbreviations in Russian texts. My speech will consist of 4 parts. First of all, we need to discuss what is abbreviation lemmatization. Then I will describe our 2 approaches to this problem, and then I will what is abbreviations lemmatization? What is lemmatization itself? Lemmatization is a process of matching a word to its normal form. For example, for verbs, it's infinitive. For nouns, it is singular and nominative case. Some examples are shown on the slide. And is this problem any complex? Yeah, it is. And for languages with rich inflection system, it is more complex, such as, for example, Russian. First problem is that there are many word forms of one lemma possible. The second problem is that there is homonymy in the language. So one form can be matched to different lemmas based on their context. For example, it's a well-known example, stali can be matched to stal as a noun or to быть, стать as verb. And is lemmatization maybe important task? In dark ancient times when everyone used word-to-vec models or some other simple models for creating embeddings, yeah, it was very important because their model was not so good and the data sets were rather small. So it was important to match all words to their lemmas because there is not so much difference between some forms of one lemma. But when we talk about big models, LLM maybe, their lemmatization it is not so important today. Because the models are trained on very big corpora where each word form can be mentioned many times, so we can just use word forms and tokenize them. But lemmatization is rather important for linguists, classical linguists, not computational ones. And there is important task of finding all examples of some lemma in the text, not just word forms, but all word forms of any lemma. And on the slide, you can see interface of Russian National Corpus, and for lemma linguistica, there is an example for linguistica. So we need first match words to their lemmas and then use lemmas as some search attribute. And in lemmatization, there are many solutions. Classical ones are Pymorphy and MyStem. Their quality was not so great, so there are many better solutions today. For example, our model Rubik is one of the best ones. It is LSTM encoder with 3 decoders. One of them is decoding lemmas. But and these solutions are rather good. Only 1.1% of errors. And is this quality great? Yes, but actually no. Because when we speak of corpora with a billion words, 1% of errors is about 10 millions of errors and of incorrectly lemmatized tokens. So all the errors should be corrected to improve the experience of linguists of getting their research results better. And when we try to analyze which errors our Rubik model makes, there one of the biggest problems was abbreviation lemmatization, because abbreviation and its lemma is very hard to understand without its context. And when we use some solutions which lemmatize based on some rules, like cutting the end of word form and adding some characters to create a lemma, these abbreviations are very complex to analyze. So we found some examples of abbreviations in our data set and discovered that existing solutions have rather poor performance on this problem. For example, Pymorphy and MyStem have no support for this problem. Rubik has bad performance due to its architecture, and some generative models like Stanza have bad performance because of a lack of such examples in the training set, because there are maybe one abbreviation per 100 words in the training set. So these examples are not very popular, and model cannot proceed any good. So we extracted some abbreviations from our training data set. We used 2 sets of criteria, and the total size of created data set was about 3.5 thousand of examples. And we analyzed them and found that the most popular abbreviation is G, could be God or Gorod. Other popular abbreviations are DT and so on. The 10 most common abbreviations account for 60% of all abbreviations in the dataset. We also discovered that most of the abbreviations can have only one lemma in the training set, so we can just lemmatize them by just mapping them to their only possible lemma. But there are a few, not just a few, about 40 examples when abbreviation can have more than one possible lemma. And we need to lemmatize them somehow. We tried 2 approaches. The first one was generative approach. We used some pre-trained models to generate a lemma for an abbreviation based on its representation. And we tried a classification approach. As I said before, only 10 most popular abbreviations account for 60%. So if we create a few classifiers, a family of classifiers for most popular cases, it can be good for practical use. So generative approach. We tried some experiments with our original data set. Its size was about 3.5 items, 3.5 thousand items. We also expanded it by adding all tokens with tag abr, and these added to us to the data set about 9,000 more examples more. And we also experimented with adding just random tokens, 100,000 of them. We tried 2 sub-approaches. First of all, fine-tuning models. We tried with 3 models, BART, MBART, and MT5. There are well-known models. We also experimented a little with a prompt-based model, but there is a problem with such an application because we want to lemmatize a huge corpus, about 1 billion of words. So there will be about 10 to 15 million of abbreviations. So some big models can be computed only in a very long time, which is inappropriate for us. We tried some data representation for our fine-tuning task. Morphology itself, morphology with context of the abbreviation, form mask, and form markers. There are our results. The Rubik baseline is on the bottom of the slide. As you can see, it creates correct lemmas in about 84% of the cases. And the best model was embarked with 4 markers. Also, we found that T-Pro model, which we use as prompt-based model, has a poor performance, which can be due to insufficient prompt engineering, or we can maybe do some more research in this field to prove that LLMs are not very good for lemmatizing abbreviations today. There are some examples of errors of our model. As you can see, rare abbreviations are rather complex for generative approaches. Like some measurement units can be mentioned only in some scientific or technical papers, and they are not very common in the Russian National Corpus. We also tried a classification approach. As I mentioned before, we can create a few classifiers to lemmatize most of the cases. We created 10 groups of abbreviations with more than one possible lemma, and created 10 classifiers. We used well-known models Rubert and Ruraberta and fine-tuned them for 5 epochs. As data representation, we use the sentence itself. When there was more than one possible abbreviation for this classifier in the sentence, we just masked other one with its lemma. So for a sentence with kv 40 kv metrov, we created 2 examples: kvartira 40 kv metrov and kv 40 квадратных метров. These are our results. As you can see, in most cases, the classifiers have done really good. But there was one problem case. It was abbreviation PR, and we studied it more and discovered that the one lemma prochi is easy distinguishable from the other two. But when we speak about prospect, avenue, and проезд passage or drive, the contexts are very similar, and we believe that even human cannot correctly lemmatize them in all cases. So, to the conclusion. First of all, the best result among generative approaches was achieved by embarked model using abbreviation context. It's not very surprising, but it shows that this model can be used in some practical approaches. Also, the main limitation of this model is poor performance with rare cases. The second important thing that we found is that a significant number, about 80% of abbreviations, can be solved using a few 10 classification models. And this approach has a very good quality on cases where there are no lemmas with very similar contexts like проезд and prospect. We are planning to implement these classifiers in our corpus, in Russian National Corpus, and you can maybe in May or maybe in June just try it yourself. On our website, there are QRs for our website and Telegram channel, where we are posting our news more frequently. Okay, thank you for your attention.
Thank you. Other questions from the audience? Yeah, please.
Thank you for your interesting presentation. I have a small question. As I understand, if you use generative models, then you have sometimes hallucinations. But do you think about some automatic post-processing for hallucination detection in generative pipeline?
Yes, of course. If on this slide you can see it, we have here as generative approaches BART and BART post-process. There is BART vanilla BART fine-tuned on our data and vanilla BART with post-processing,
Okay.
and it slightly improves the performance. Yes. The problem is that BART, even Rubik, all existing solutions for lemmatizing Russian are not very good linguistically informed. So they can create some lemmas which are not possible from each Russian speaker. And we have such examples in our corpus, but we are trying to fix them using just some simply heuristics. And I believe that there can be some major improvement if we can teach a model to use to understand the rules of the language here. So it wouldn't create some impossible lemmas.
Thank you, but I think that in many applications we don't have understand some linguistical nature of abbreviation, lemmatization. For example, if we build some retrieval augmented generation pipelines, we have to rewrite user questions with abbreviations. For example, we have to rewrite some documents, normalized documents, and this pipeline can help to do as black box, for example, but we need to estimate uncertainty of this black box using some post-processing.
Yeah, it can be solutions.
Thank you.
Thank you.
Thank you for your presentation. My question is, ability to lemmatize abbreviation consisting of two words like главврач, физкультура, самбо, and so on. And like, have you considered this task maybe?
In this work actually no, but there is another problem with such words, and here we're trying to create some normalizing model. We just created a data set and tried some baselines, so it's not perfect work today, but we try to recreate the full forms of such shortened versions, and this can also be used in normalizing social networks where such abbreviations are very popular when you just combine two words into one. And I think maybe next year I will present it.
Okay, thank you.
Thank you.
Thank you. Any other questions? Yeah, please.
Hello, thank you for your presentation. I have one question. Would you consider to do your maybe continual pre-training of BART model to improve your models to improve your pre-train for fine-tuning for specific tasks?
Thank you for your question. Maybe we have not a huge data set, but it is about 2 billion words today, and we believe that they are much less noisy than any common data sets. So maybe we'll try that. And today we just trying to conduct some experiments with tokenizers based on some linguistics approaches, but not with pre-training big models.
Okay, thank you.
Okay, thank you.
It was really short question. Okay, there was another one. Yeah.
Thank you for your speech. And what about abbreviations such as names of some companies or NGO or something like this?
In these experiments, we experimented only with such examples, and the abbreviations which consists of some initials or company names, they are marked with init or com text, so we didn't consider them. Maybe there should be another model to lemmatize them, maybe with some named entity recognition model combined with some named entity recognition model, because such cases, I believe in most cases, can be just mapped to their known full form. I don't think one can reconstruct Новосибирский государственный университет based on NGU. I don't think that rather small models like BART can reconstruct them. Maybe large language models can, but there is another option to investigate such cases. And I want to repeat that we have a computational limitation when we speak about lemmatization of huge corpus. We need to consider the option that we need to lemmatize maybe some thousands of tokens per second. In the opposite case, the lemmatization will take forever, and we can show them. We can use such model in our corpus.
Okay, thank you.
Thank you.
Thank you. We had another question there.
Hello. As I understand, the main goal of using classifier for this task is to deduce similar looking abbreviation from the context. So to understand such cases like you mentioned prospect and proest. Have you studied the possibility of deducing abbreviations that are not part of training set? That is it possible to deduce from the context the abbreviation you haven't had in your training set?
Okay, thank you. We studied the data set and discovered that short abbreviations like 1 or 2 letters are usually popular, and they have well-known lemmas. And when we speak about some long abbreviations, when we just replacing a few letters on the end of the string with dot, then these abbreviation, I believe, have only one possible lemma, and for such long cases, maybe generative approach will be better. But for our cases, as you can see, there are only 1 or 2 letters abbreviations. There are 5 of 1 letter and 5 of 2 letters. And human do not use such popular abbreviation to abbreviate some unknown word. Well-known abbreviations are used only for well-known lemmas.
Okay, I understand. Thank you. So you haven't had enough data for that.
Yes, and I'm not sure if it is practically important to investigate such cases. So there is just a small possibility that one of these 10 abbreviation could have another possible lemma, which was not mentioned in the dataset. So we are here trying to solve a practical problem, not any fundamental problem. And for our case, this is, I believe, enough.
Thank you.
Thank you.
Thank you. Any other questions from the audience? Then I allow myself one question. Maybe I missed it, but have you considered to have some hybrid approach? So like approach with on the one side with a classifier and with the like standard old-fashioned dictionary?
For classifier approach, we can there are among the popular lemmas, there are about 40 popular lemmas, and for other abbreviations, for many of them, there is only one possible lemma. So there is no interest of mapping just one abbreviation to one possible lemma. The accuracy will be 1, but it is not. It's not showing the real result, because there can be a huge number of some abbreviations that are not mentioned in the training set. So we can just use a dictionary. We can use dictionary for such cases that we already found in the training set, but for many examples which are used only one in the actual corpus, not in the training set, it can be used. So I believe we need to use some generative approach here.
But using the dictionary approach, you would reduce the hallucinations, as far as it seems to me, no?
Yes, I believe the solution which we will implement in the corpus will consist of hybrid, will be hybrid. So the most popular we just lematize with classifiers. Then such cases that we found in the training set with just one lemma, we will use a dictionary for them. And for other cases, there are, I believe, thousands of them, we will use a generative approach, embarked. I believe it would be embarked.
Okay, thank you.